In this video, you will learn why it's important to adjust the heat curve with ECL, about the factors that influence the setting of slope of the heat curve, how to adjust the heat curve to ensure optimized heating system, through a demonstration with the ECL. Throughout the video, ECL refers to an ECL Comfort 210 or 310 controller. The weather compensation feature of the ECL Comfort controller adjusts the flow temperature in the heating circuits based on the measured outside temperature to reach room temperature of 20 degrees Celsius. The heat curve is the most important setting for the weather compensation feature to operate optimally, thereby increasing the energy efficiency of the heating system. The slope of the heat curve needs to be well adjusted to ensure desired room temperature depending on the outdoor temperature. Goal is to have as low slope as possible but still reach the desired room temperature. The heat curve slope needs to be set after installation as part of commissioning the heating installation with ECL Comfort controller. It also needs to be regularly optimized, especially when outdoor temperature is below 0 degrees Celsius. The adjustment of the slope is done by changing the value in ECL Comfort controller heat curve menu. The default value is 1.0. However, the change is advised to be done in small steps by 0.1 at a time in a period of 1 to 2 weeks. The desired room temperature also has influence on the flow temperature. For example, the flow temperature will be higher if the desired room temperature is increased. Now we will demonstrate how to find the heat curve in the menu of the ECL. Now we will demonstrate how to adjust the slope by changing the value. After installation of the ECL Comfort controller, the slope must be set as a starting point, which can then be optimized further afterwards. The initial value of the slope depends on two factors. First, the type of heating system, floor heating or radiators, and second, heat demand, building insulation. These factors are to be taken into account when deciding on the starting value for the heat curve slope. Goal is to have as low slope as possible, but still reach the desired room temperature and energy efficiency of the heating system. The table presented helps to choose the initial value of the heat curve slope, and then step by step, the slope can be optimized to ensure energy efficiency without compromising the thermal comfort. How to use the table. First, determine the heating system type in the building. This can be floor heating or radiator heating. Floor heating requires a lower flow temperature than radiator heating. The smaller the radiators, the higher a flow temperature is required. Then determine the heat demand. The heat demand is lower, the better the building is insulated. The lower the heat demand is, the lower the flow temperature can be. The table also lists the desired flow temperatures at +5, -5, and -15 degrees Celsius outdoor temperature. These flow temperatures correspond to the typical needs for a given heating system type in a building with a given heat demand. Example, a newly built house has floor heating and is well insulated, so the heat demand is low. The initial value of the slope can then be set to 0.6. Another example, the building has medium-sized radiators, but the building is well insulated, so the heat demand is low. The initial value of the slope can then be in the range from 0.6 to 1.4. In this case, the default value of 1.0 may be a good initial value of the slope. After the initial value of the heat curve is set, adjust it in small steps, which is approximately 0.1 value within a week interval to optimize it further. The impact of adjusting the heat curve slope is higher when the outdoor temperature is low, so it's recommended to do the optimization of the slope when the outdoor temperature is below 0 degrees Celsius.